Does anybody have any questions on those? They were pretty easy. Robbie?
Could you do 30?
Sure. Drop that in. So the directions here ask us to convert this into standard form and leave the answer exact if possible. So I observe that 240 degrees is a unit circle value, so I can give this as an exact answer. So that means that the 240, the x side is the short side, so cosine of 240 is a half, and sine 240 is root 3 over 2. Oops, and we're in the third quadrant, so those are both negative. So I'd get 3 or negative 3 over 2 minus 3 root 3 over 2i.
Thank you.
Was that good enough? And that's all she really wrote there. Now you probably would have looked stuff up off the unit circle, but like Mr. Kulik's not got it memorized, so to speak, but like just kind of like there's only, it's like, look, I know one's going to be a half, the other's going to be root 3 over 2. I just have to figure out like which one is the short one, which one's the long one. So I just pictured the circle. It's like, where's that at? Okay, the x side is the short side. Yeah. So it's like kind of memorized. I don't know. I try not to memorize things if I don't have to, just like kind of understand it. Jack?
Can you do 37?
Yeah, so same idea here. The only issue is 68 isn't a unit circle value. So if I'm going to do 37, it just has to be with the calculator. So I'd want to make sure I'm in degree mode. So I'm going to do 12 cosine 68. And then 12 sine 68. So I have, 4.5 plus 11.13i. And I'm done. Is that okay? Oh, been there, done that. It's a funny mistake. And the way he said it is like, oh. It's math teacher that funny.
Yeah. Exactly.
Yeah.
It's like, yeah.
Yeah. All right. How's everything else going? Is that okay? Again, these were I think pretty easy things to do, right? Today we're going to do section 11.2, which is about multiplication and division. So let's go back to last year. If I multiply two complex numbers in standard form, say I have like 2 minus 3i times 5 plus 6i. How do I do that? If I'm going to multiply these out, what do I do? FOIL, yeah. So 2 times 5 is 10. 2 times 6i is 12i. Negative 3i times 5 is negative 15i. And negative 3i times 6i is negative 18i squared. That's pretty easy so far. What do I do from here? Well, what's I squared? Negative 1. Good. So if I combine my like terms now, I have 10 minus a negative 18, so really 28. And 12i minus 15i is negative 3i. No big deal, right? Keep in mind that there is like one special situation when we do these kind of things where life can be really easy for us. So what if I have like 4 plus 5i times 4 minus 5i? Does anything stand out to you here? This looks like, to me, a difference of 2 squares. Right? Does that recognize you guys there? So I can avoid the foiling by there, or by doing that. So this is just going to be 4 squared minus 5i squared. So 16 plus 25 is what that'll simplify down to. You guys catch why it turned into plus 25 there? If you don't, you can ask. It's okay. You see the I squared is the -1, and then the negative of a negative makes it the positive, right? Just as a piece of vocab, when we see two things like this that are the same with different signs in the middle, do you remember the special math name we give for things like this? They're called conjugates. Just as a little bit of review from last year on stuff. I know that this is an ACT weekend, so, you know, mention some stuff that we would have done last year. Algebra 2 is a pretty ACT heavy section or topic. Okay. So, what if we want to do this in trigonometric form? Well, I don't know how that's going to, I know how that's going to work, but we don't know how that's really going to work. So let's see if we can just do this in the general case. And then see if we can work out like a shortcut or something. So I'll say we have two complex numbers, z1 and z2, where z1 is r1 times cosine theta 1 plus I times theta 1. And z2 is r2 times cosine theta 2 plus I times sine theta 2. So if I want to multiply these two things together, well, you just kind of write them next to each other. Now, the way I've written this, is there really any need for those brackets to be there? No, man, right? There's just like four things multiplied to each other, right? R1, a parenthesis, R2, and a parenthesis, just four things multiplied together. Everybody see that? So let's drop those guys out of there. And since it's just four things multiplied together, I can multiply these things together in any order I want, right? So I'm going to pull the R1 and R2 here out front. And then I'll leave the parentheses right next to each other. So far, so good. And at this point, it's like, okay, let's FOIL those parentheses out. There's nothing really else left to do. So I get cosine theta 1 times cosine theta 2 plus I times cosine theta 1 times sine theta 2 plus I times sine theta 1 times cosine theta 2 plus I squared sine theta 1 times sine theta 2. hey, and remember, we got an I squared here, so what's I squared? -1. Okay, so I got all this stuff inside the parenthesis there. I see two things that have I's in it and two things that don't have I's in it. I'm going to group those things together. So I'll put the stuff without the I's first. So I have cosine theta 1 times cosine theta 2. Now it's minus sine theta 1 times sine theta 2 plus, and we'll have it do that, I times cosine theta 1 sine theta 2 plus sine theta 1 cosine theta 2 . And you're like, Mr. Kulik, this is not getting any better. And I say, ah ha ha, not so fast. Does that look familiar? It should. That is an identity. Which identity is it? It's the cosine of the sum of two angles. What about this one? Does that look familiar? It should, because it's another identity. It's the sine of the sum of two angles. And yowza, 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 that's a pretty nice stinking formula. Because what's the takeaway here? To multiply two complex numbers in trigonometric forms, multiply the r's and add the angles. Done. This is a mental math problem now, which is pretty stinking great, right? Let's do an example just to kind of really hammer that home. So let's say Z1 is 4 times cosine 172 plus I times sine 172, and Z2 is 7 times cosine 13 plus I sine 13. So Z1 times Z2 is going to be the multiply the r's together and add the angles together. So what do I get? 28 cosine, or 28 times cosine 185 plus I sine 185. That is a mental math problem. I can dig it. Easier, really, than doing the standard form one, right? This you can do in your head. Probably can't FOIL out the two complex numbers in your head. That's a little bit harder to hold all that stuff together. This, I can multiply 4 times 7. I can add 172 and 13. No problemo. Which is very nice. Okay. Okay. So let's talk now about division in standard form. So let's say, for example, I have, 3 minus 6i divided by 5 plus, or negative 5 plus 2i. So when I do a division problem like this, I like to think about it rather as a fraction. Remember, those are still the same thing, dividing in a fraction. Everybody agree? So the issue here is that I have i's in the denominator, right? For me to complete the division, I need to get a standard form complex number back. So I can't have any i's in the denominator of my fractions. I's in the numerator, fine. Denominator. So to finish the division, what I really need to do is get the I out of the denominator there. How do I do that? If I multiply I over I, the I is going to distribute into the denominator, so I'll end up with the I on the 5. It'll get rid of the I squared on the 2, but, you know.
Multiply by the conjugate.
There you go. Yes, Aiden. Multiply by the conjugate of the denominator. And I got to do that to the top and bottom. Because really what I'm doing here is multiplying by 1, so it doesn't change anything. Everybody's cool with what I did? Everybody cool with how I found the conjugate? Just same thing, but different sign in the middle. So now we just are going to FOIL everything out. So in the numerator, I get negative 15 minus 6i plus 30i plus 12i squared. And in the denominator, I'm just get 25 plus 4. Again, I use the difference of two squares multiplication pattern. You can always FOIL that out. You'll get the same answer. Just takes a couple extra steps, and Mr. Kulik's about brevity, my man. So I'm going to take that shortcut whenever I can. I would prefer to think about it as being efficient. It sounds less negative than taking a shortcut. All right, so if I combine like terms in the numerator, remember I squared is negative 1, so I have negative 27 plus 24i over 29. And really the best way you'd want to write this would be as two fractions, so it's really clear what is the real part and what is the imaginary part. Needless to say that if you could have reduced those fractions, you should do that. Obviously, in this case, there's no reducing that can be done. Everybody's cool with that? So that's kind of a hassle, right? You have to potentially, FOIL out two complex numbers and like multiply by the conjugate or whatever. In trigonometric form, though, if we take the two, or I wonder if there's a formula there. What do you guys think? Yeah, I wouldn't be doing this if there wasn't, right? Anybody want to take a guess as to what the formula would be? Use what you know about the multiplication formula. Yeah, that's exactly the formula. Isn't that wonderful when like it just works out like by common sense that that's what you'd get? Now, I'm not going to go do the derivation like we did last time. It's really the same derivation. There's a couple of extra identities in there because when you multiply by the conjugate, the denominator turns into the Pythagorean, and it just drops out, and the numerator stays there, and it's fine. It's whatever. But you guys you could do that if you wanted to. It's basically the same thing that we did before, so I'm just going to skip it. But that's pretty nice, right? So for example, if I wanted to, or if I had the two complex numbers here, So there's my two complex numbers, and I want to do the division of them. What am I going to write here? Yeah. Same thing. Yeah, very good. Now, what's the only kind of hassle here? I have these fractions, so to subtract these two fractions, what do I need? Common denominator. What would the common denominator be? 21. I was talking to fractions the other day. They said they hated you too. That's harsh, right? They were like, she's always dogging on us. There's nothing wrong with us. We're just numbers. It feels like, you know, like disrespectful or something. We're really important numbers. Everybody's okay with this? Now keep in mind, this trigonometric multiplication division formulas are super easy to use, right? If you prefer, you could take your division problem in standard form, and instead of doing it in standard form, you could convert those standard form complex numbers to trigonometric forms, and then use the formula, and then convert it back out. If you wanted to do that, that's a valid way of doing things. And if I were like writing a computer program that had to deal with a lot of complex numbers, that's probably what I would do, is the input, I would just turn everything into trigonometric form so that when I do the computations, it's really easy to do the computations, to code that in, rather than coding in the, you know, how to do it in standard form, which would be a little bit more difficult, because now you have to talk about like, how am I going to define a conjugate, which is like kind of a hassle, or takes a lot of extra coding versus just, I'm going to just convert it out and then deal with it, which is, you know, but either way of doing it is fine. Like, surely if you have two standard form ones, you can multiply it out like we would have last year, divide it out like we would have last year. That's fine. Also, no problem. I just wanted to point out that, like, this creates a potential shortcut if you have to do, like, a massive number of these things, right? Okay. That was it for this section. We're going to stop here, mostly because we had a test already this week, and like there's only 3 sections in here, and the third section is kind of the hard one, so like I don't really want to cram that down your throat right now. So I think at this point you guys should be able to do up through 64. So that's a couple more. If you're already caught up through 40, again, what we did today was pretty stinking easy. I don't see any reason why you couldn't finish this here in class and just not have to worry about this. Gone and out of the way. Also want to say here before we go that probably over spring break, to get ready for the seniors' departure, I'm going to have to put in the drops. So you'll see your grades move over spring break. Because when the seniors come back, they're going to have to make their decision about whether they want to do like the retake or the double and get ready for exams and all that kind of thing. So I'm going to have all that stuff done. And I can't do it individually with the drops. So I have to do it for everybody. So you're going to see everybody's grade move over spring break. As we continue on with the juniors, as we do more homework quizzes and more homeworks or whatever, the computer automatically adjusts the drops. You won't be able to see on your end what's being dropped, but I promise you the computer's dropping the lowest things. And I promise you when new scores come in, whatever's getting dropped is up, like re-updated, and will drop the new lowest things. I promise you it's doing it. But you're not going to see that big drop again at the end of the semester because we're doing it, that part of the drops now. You won't see your grade bump again until we put in the double. So there's not won't be another grade jump after spring break or whatever until we do the double or retake. Just to give everybody a heads up before I do that. I don't want to get a bunch of emails over spring break when somebody's like, oh my God, what just happened? Because some of us are that person, you know? It's like, I didn't see anything new come in. Why did my grade move? It's like, oh boy. Everybody's cool though? No big deal?